An Excel spreadsheet in Sky that can grow and grow and grow and grow and grow and grow. It's great for lookups and for massive scale on your website. Relational database service is amazingly what it sounds like. They will host MySQL for you. So if you don't, you can obviously run it on your own machine and configure it and so forth. If you don't want to do that, you simply say, I need a database. You can sign up for this service. They'll give you a pointer to it. And while it was MySQL, they've recently opened up actual SQL Server and some other options. Simple storage service. This is probably their crown jewel. This is where they started, which is object storage in the sky. We'll talk a little bit more about this on a coming slide here, but it's blob storage in the sky. Put a file up, pull it down. Really high persistence and reliability. They have had some availability issues which are different, but their reliability is very high. They just announced 11 nines of reliability on that data, which is huge. Elastic block storage is a subset of that storage. Think of it as a sand in the sky. So you set up a mountable block volume that you can then mount. But unlike S3, where you have individual files that are URL accessible, these are blocks that are mounted to one of your virtual machine images and are sort of locked to that virtual machine image. Simple queue service is just that. It's sort of MSMQ in the sky or queue-based messaging. Very simple. You get 8K that you write to and read from, and they've got some stuff. We'll talk about that. SNS is sort of pub/sub in the sky. So if you want to do multicast and pub/sub messaging, simple notification services allow you to do that. On the Microsoft side, their service bus provides some similar functionality. CloudWatch we talked about just a minute ago. Virtual Private Cloud, this is again, relatively new offering. This is designed to help people who are scared to get into the cloud, particularly corporations, sort of step into that space. And what they'll allow you to do is set up essentially an IPsec virtual private network sort of extend your network into theirs. So traffic from your nodes from the nodes that you're hosting there don't go directly out into the internet. That it's locked between their network and yours, and you can control it out. So it's sort of an interesting way to play without some of the fears. Elastic load balancing is again, a relatively new feature where you can have multiple web heads and basically have a load balancer. It's a website, or it's website or API configurable. You just say, given this IP address, I want you to direct traffic with sticky sessions or not across these nodes that I'm hosting inside. Import and export. This one's funny to me because I've been working a lot, as part of our project, we've been working a lot on large-scale data movement. So petascale data movement from scientific domains in and out of the cloud and how we interact with that. About a year ago, someone at Amazon had the brilliant idea that FedEx is a faster network than the internet. So they have a feature in a service now where you can actually, depending on the size of the data, you can actually FedEx them USB disks, and they will load them directly in the cloud, or export to them. And they've sort of systematized it. They'll charge you for it, but it's a lot faster and significantly cheaper than actually the network charges that you would get for sending that. So if you have large scale, SneakerNet lives on, guys. So a couple of topics we're going to dig just a little bit deeper into. So S3, the store standard. They're both, or sort of all of the cloud platforms are really, they work hard to sort of genericize this. They say it's objects. They don't talk about files, but at the end of the day, it's files, right? It's the easiest way to think about it. You can store files, and I think this 5 gigabyte limit has changed. I think it's going actually higher. But basically, you can put objects into the sky, up into the cloud. Think of it as arrays of bits. You can do whatever you want to with them. They can actually be full files or be partial files, however you want to do it. So if you're doing something that needs sort of chunked access, you can sort of have your own approach to doing chunked access and actually have individual blobs that you interact and sort of aggregate for your users. They have this notion of buckets, which if you play with Azure are similar to containers. It's just the root block into which you store things. They have this notion of a key. And I probably should have put up a sample of this. This is where everyone has sort of both on the Windows side, or sort of the Azure side, and the Amazon side, and the Rackspace side, it all sort of, our minds think in file structures, right? Because we've been trained to do that. So what you'll do is, when you put a blob up there, your URL is something like http storage account.amazonaws.com/bucket name, and then key name. So they don't have any restrictions on what that key name is other than the length. So what people will do is they'll put slashes in that key name to give you the sense of a folder structure. And there are a lot of tools, we'll look at a couple in a few minutes, that will do some clever things with, when it's scanning and showing you different key names with that slash to sort of represent it to you as a folder structure. So the key is you can basically do anything with it. But everything everything you put up there is URL accessible, and you can have access controls and so forth. It's very nice. SQS, simple queue service. You create a queue, you can have not as many queues. I think there's a bunch, but you can have unlimited queues per account, messages per queue. We'll talk a little bit about this more when we get into the application design. But part of successfully using the cloud, and successfully developing for the cloud, is to understand how the cloud was designed. If you talk to any of the Amazon developers, they'll say, we assume failure, right? Which is to a degree, is a little bit of a foreign concept to a lot of devs. We assume failure. We assume our server is going to go down. We assume we're going to lose connectivity. We assume we're going to lose X, right? So everything they've designed is assuming failure, assuming that equipment fails. And it's actually pretty easy if you do sort of the MTBF calculations on your hardware. If on a single machine, your MTBF, if you aggregate everything and sort of look at your worst case MTBF, it's probably pretty good. When you scale that to 1,000, it gets worse, right? Because your risk ratios go up. If you scale it to 10 or 20,000, you're having stuff fail constantly. You'll have many nodes fail every day. You'll have many hard drives fail. They just spread across your collection. So they assume failure. So one of the things they encourage you to do, and this is true on the Azure side, they actually used to force you down this model a little bit more on the programming side. Amazon doesn't force you, but they sort of encourage you to break your application logic up into consumable chunks, which is you really should be doing anyway, and then use queue-based message passing between your application blocks. So you have this sort of persistence lock-based queue service that you pass messages to or you pull messages off of, and if your node fails while it's doing that process, nothing's happened. You spin up a new node, it will pick up that task again and continue on. So queues are really important when you're thinking about the cloud. Technically, it's really important anytime you're wanting to scale out an application design. The cloud sort of make it a little more accessible and sort of push or force you that direction. EC2, we talked about it a minute ago. We talked about AMIs, and we'll briefly talk about some of the other things here, like kernels and things like that. But this is actually a slide deck I stole from Amazon. SlideShare is a great site. And I wanted to point out, they'll mention things like launch in less than 2 minutes. Launch versus being accessible are different statements. So yes, you can click go, and from the time you start to the time you hit the go button will be less than 2 minutes, but then you can access it. So I'll give you some comments about what's a little more reliability, or a little more accurate there. Inter-service bandwidth is free. That's actually a big piece. So if you look at the modeling, if you look at the pricing, they nickel and dime you for everything, right? But that's how the cloud model works, which is fine, assuming you understand where that all fits. So you get charged for, pennies per hour that your node is active. You get charged for gigabyte month that your data stored in their service. You get charged for certain IO operations. And again, it's very, very little, but they sort of add up. You get charged for bandwidth in and out of Amazon's data centers. You do not get charged for bandwidth internal to Amazon data centers. So that would play in